Demand energy equality is a grassroots approach to the energy dilemma that we face in this country, which also has a social dimension to it. One of the main things we do is we run educational energy workshops, which primarily involve teaching people how to build solar panels, because that's a good way of engaging people in energy and taking it from being an abstract concept into something they can actually understand, in order that they might actually change their behaviour, because one of our main messages is one of energy demand reduction.
It's not in an energy company's interest for people to consume less power. That would be going against their profit motive, which is what they need to have in order to provide a service to their shareholders. And so what Demand Energy Equality is trying to do is enable people to see the need, both from a climate change perspective and a fuel poverty, energy inequality perspective, to reduce their demand, which the government and energy companies, so long as they follow a neoliberalist, profit-driven capitalist agenda, will never go about doing.
The social dimension is very important to the project as well, because we focus as much of our work as possible on low-income groups, because low-income groups are traditionally, in policy terms, left out of the measures taken to green our electricity supply, but they rarely tend to take into account the energy poverty that exists and the energy inequality that exists, and in some cases actually make it worse.
An example of how government and energy companies are trying to encourage change, which is increasing social inequality, is through the feed-in tariff, which is a mechanism designed to encourage solar panels, i.e. to address climate change, but because it's done through a neoliberalist agenda, the way that manifests itself is that if you've got a solar panel, you the way that you generate your income is that everyone who doesn't have a solar panel, or everyone who consumes electricity, pays into a pot, and then that money goes to the individuals who have the solar panel.
The first barrier to low-income groups, low-income houses, or individuals, or communities, or demographics, however you want to describe it, becoming less vulnerable and becoming less exploited is through empowerment. But without knowledge, without understanding the issue with which you're actually faced, there's no way you can empower yourself to it. So education is absolutely basic. If people don't understand the situation they're in, then they're not going to be able to stand up for themselves and skill themselves up and inform themselves in a way that could improve their situation.
My initial sort of solitary idea came about through some kind of discussions around having something called a solar tree at Glastonbury Festival. So I came up with a proposal. So this proposal was sitting in the ether in Bristol, in particular in Bristol, and connections of connections. Dan kind of found images of this, contacted me, and started chatting about his project.
So in the course of running workshops, I met a guy who knew a guy, and that guy turned out to be John Packer. So John had these designs already made. So it was this amazing fluke that I was thinking about a solar tree, or Demand Energy Equality was thinking about a solar tree at the same time as John was.
So my role is just to make this tree thing, which is I always envisaged as being more of a visual thing and an educational thing, rather than something that was going to be highly efficient, because the conventional knowledge is that photovoltaics have to all face the same direction. But the waters are now very muddy around this, due to some slightly questionable research in the States, which has got some publicity.
This guy, this young guy, said to me, I've heard of this kid in America. He's 13, and he reckons that if you follow the Fibonacci sequence and the angles on a tree, that you can get more power output over the course of a year than you would from the same surface flat panel. He won a scholarship, I think, to something like the Royal Geographical Society in America. So there are academics now in America who are really sort of taking these ideas seriously.
So what me and Dan are going to do is actually get some empirical data. We're going to set up the same size of standard PV array using the same recycled, scrap solar cells. So we'll have the same theoretical output, but we're going to empirically compare the two over the year and just find out. In terms of warming the hearts of the average chap in the street to the idea of solar being a good idea, having something that's nice sculpturally, I think is just goes a hell of a long way towards that.
So Edible Futures is this really great project. They've got this plant nursery out in Brislington, and that's called Edible Futures, and they grow edible perennials for community spaces around Bristol so that people have a way of accessing free food. But in order to grow those plants, they need to have an irrigation system, and that irrigation system needs to be powered. And because the nursery doesn't have any power, that's what the tree is going to do. So the energy system is going to be linked up to the food system. So I don't know, some people call it like permaculture or some sort of weird symbiotic relationship.
Edible Futures is an edible landscaping project. So what that means is we've got here on this site called The Rock in Brislington an edible perennial nursery. So this is a place where we're propagating loads and loads of fruit trees, nut trees, soft fruit bushes, and the less common thing is the edible perennial vegetables. We want to take like marginal bits of urban land that aren't being used for anything and turn them into productive landscapes. So this little salad here is called radicchio, mainstay of French culinary design, often eaten with blue cheese, and this is one of the many things that we're selling to our main buyer called Poco, which is a little eco cafe in Stokes Croft. If we turn around, we've also got one of my favourite plants on the whole site, nasturtium, renowned for its delicious edible flowers. Also attracts a beneficial insect. So this is part of a really diverse edible landscape here in the polytunnel. What we're looking at the moment globally is a food crisis, okay, where we've got such long supply chains in terms of getting food to urban consumers that it's reliant on an awful lot of fossil fuels. Yeah. It's reliant on fossil fuels not only for long supply chains but also kind of petrochemical agriculture and the countrysides, or increasingly in totally different countries on the other side of the world, is what is needed to feed like someone like me, the urban consumer in Bristol. So what urban agriculture is about compressing those supply chains so that this food, which is grown here, can go and feed someone, a mile away. It's been piloted in Cuba, and we've seen in Havana, for example, since the 90s, they've had an explosion in urban food production to the extent that Havana now exports vegetables, which, for a capital city is the most incredible achievement, and that's what we need to mimic all over the world. Because all that Cuba's had is like peak oil 10 years before with the collapse of the Soviet Union, but we're going to get those same stresses here, places like London, places like Bristol, New York, wherever, and so we need to be kind of like at least drawing on that model, Cuba's model of the urban agricultural revolution. That's what we're trying to kind of pioneer here at Edible Futures.
So we went down to Edible Futures for the site assessment to work out where the tree was going to go, and the two big considerations were where the sun was and shading, and we wanted to make sure that the tree got lots of sun, and diggable soil such that we could bury the anchor. But those two things are obviously what plants want. In the end, we decided to go where there was slightly stonier soil, where Humphrey wasn't already growing plants.
There's a big environmental scene in Bristol, so it would have been very easy to fill the places, the workshops, with activists and kind of environmentalists, but that's not really what we wanted to do, which is why we had to invest quite a lot of time kind of building relationships with community groups and charities.
It was one of the most difficult presentations I've probably ever done, because it was to an audience who didn't necessarily understand the entire background of what we're about and what we're trying to achieve, whereas a lot of the stuff that I've done in the past has been not preaching to the converted, but engaging in an audience who at least has some of the same motivations, goals, ambitions that you do. What we're doing at the moment is a specific project where we're building this thing called a solar tree, which is a bit bizarre, hasn't really been done before, ever.
Actually, I think I've seen one 10 weeks ago.
Yeah? Just outside here?
No, there was one.
So yeah, Bristol Drugs Project presentation was really difficult because people didn't have any of that background information. And so, yeah, we're making some really strange comments about, well, that one looks good and that one's rubbish, and like, how much is that one worth, and this sort of stuff, which are, totally fair enough comments, but they're just not the kind of comments that you would expect in a different audience. And so it becomes difficult to balance that challenge to you and what you're doing against trying to engage with those people. And so this is like cheaper than that one. And so we're always trying to like reduce our costs because, we're not trying to make this for people who can afford.
What would that cost?
That would be probably 3/4 of the cost of that one. Because that one's just.
What would that cost?
That one costs about 30 pence per watt. Yeah, really, really difficult, but really worthwhile in the end because they came along and they had a great time, and it was the best day that we had, and they were probably the most engaged people that we had because they hadn't experienced anything like it before, so they were super excited by it.
What happens if they had thunderstorm, like there was a hurricane for a week or 2 weeks? Well,
then you wouldn't be producing that. So in the winter, so December's the worst month for solar panels in this country.
Okay.
So in December, you get about a third of the output at peak than you would in the summer.
Oh.
So you still get power, but it's just less. And so having solar panels and using the power, you basically end up learning a lot more about how energy and power systems work, which then gives you the tools to make choices about how you then consume energy and how you use lighting or whatever in your house.
Okay.
So the project is about energy, and we teach that through the medium of solar panels. So the cells that we get are from Sharp, the manufacturer, who get them in turn from China. And in the transport from China, some of them end up a little bit broken or a little bit cracked. And so in effect, we're using the waste cells that would otherwise be thrown away. But in order to make them usable within the panels themselves, we need to cut them into squares. And the reason we go for squares is because when we put them together, that's the most efficient shape for capturing the most amount of light. So I've got to cut 1,600 of these. So my life's going to get a little bit boring. I turned up at John's yesterday and there was he's done completely finished 4 of the last bits, and there's 9 of them. And there's another 5 to do, and we're going to be erecting the tree tomorrow.
Yep, it's crazy in there. We've had 4 or 5 people working all day, putting hundreds and hundreds of these little crisscross pieces on, which all take time. So we've got a hell of a lot of work still to do for, in theory, tomorrow when it's supposed to be going up.
Everyone was working till about 9 o'clock last night, and everyone was really tired, but also very excited that the tree is finally going to go in. First of all, we're going to John Hacker's to pick up most of the solar tree.
Time now 26 minutes past 8 o'clock. Now, a tree is being planted at a community food project in Brislington this weekend, but this is a tree unlike any other that you've probably seen. The leaves are actually solar panels, which once operational will provide enough energy to run an irrigation system. Demand Energy Equality are the organisation behind the solar tree. Have you installed it? Is it there?
It's still being made at the moment.
Right, yes, yeah.
The really tricky bit was happening last night, where we were trying to thread all the little wires up through the various elements of all the tubes. The tree's made out of lots of steel tubes.
This is to raise awareness, isn't it, I guess? But you're talking about making them and putting them on roofs of houses, presumably, are you?
We wouldn't be able to put the panels that we teach people to make
put a minute ago.
For various sort of regulatory reasons. Part of the reason perhaps of building a tree.
In order to conserve energy, people need to understand what energy is. You can't ask someone to go into Primark and not buy a pair of trousers unless they know some contextual reason as to why they wouldn't want to buy those trousers. So that might be that the trousers are made in sweatshops in China. In the same way with energy is very, very, very abstract. What we're trying to do with solar panels is give people a contextual understanding of what energy is and how difficult it is to produce. And what it is, what volts are, what current are, what power and the difference between power and energy is. And until you get to that point, you can't say to someone, well, you need to conserve it, and otherwise, how do they do that?
You don't realise how much, until somebody actually tells you how much energy is used in boiling a kettle or anything like that. You don't really understand it until somebody really explains it to you. Today it made more sense. As long as I don't get too technical, I'll be all right.
I work at the Bristol Drugs Project. I'm a group worker down there. I work with people who are trying to emerge from addiction, various types of drug addictions. And I brought a little crew from the BDP.
I'm on the Boost programme, BDP. We knew there was a day coming out, so I come out just to have a look and to learn. And it's been enjoyable, different experience from where I come from. Yeah, it's been good for the day. Learning, isn't it? All about learning.
Yeah, I've had a really nice day. It's been really amazing learning how to make solar panels. I really thought that I'd break a lot of the glass, but it's been a really great experience for me. I think that they need to introduce this into schools as well, because I think that the children really enjoy it.
Yeah, today I've been facilitating one of the groups. We've made a couple of solar panels, had a really lovely group from Trinity, and yeah, did really well. They were really inquisitive and really seemed to enjoy it as well. It's really nice, and I think everyone by the end, they were grabbing the multimeter and putting it on the right end. They knew where the positive and negative was. They knew how it all should be flowing through it. They could do the sums and everything. So I think they properly understood how it all works. It's really nice to see.
They're like so many DNA strands.
It looks really organic, so you've got the tree branches splitting in all sorts of different directions.
Some crazy apocalyptic sculpture.
It's a kind of like fusion of the natural and the created, the urban, the man-made.
To the solar tree!
All over the 240 volts. The solar tree.
And to join